Hello and welcome to this new video of class 12th physics, and this is chapter 1, electric charges and fields. This video is part 1 of this chapter. First of all, we will discuss some daily life examples where we can feel, where we can see charge. This is a term which we have to explore later, but we will first discuss charge around us. First example, here it is. It is the spark or hearing of a crackle when we take off our synthetic shirts or nylon sweaters, particularly in dry weather. Okay, during evening and during some dark environment, if this experiment is performed, the sparks are clearly visible. The next example is the sensation of an electric shock while opening the door of a car or holding the iron bar of a bus after sliding from our seat. In this example, the important thing is first part, sliding from our seat, and next is touching the doorknob. Third example is lightning. It is very common. We see it in rainy seasons. This is the charge produced in clouds and they get leaked out to earth. Here some collection of examples. You can see children in a playground when they slide from metallic or plastic sliders, then their hairs shows some effect due to charge. The balloons attract the hairs of the girl, the balloon attracts the hairs of the cat, balloon can stick on the wall. We can feel the shock when we move on a carpet with woolen socks. So many examples. You have also seen the carrier which carries inflammable petroleum products have long metallic chains in its rear part almost touching the road. It is a security measure, preventive measure. Uh, Otherwise, what will happen? There will be an accident of fire. In order to avoid it, these chains are provided. And the explanation is there why these things happen. We will discuss it later. Okay. So we have seen the examples in our daily life whose answers actually are not answered right now. Okay. We are here in class 12th and this is the first chapter we will start now. But before going into, we must know our course. The first two chapters of class 12th deals with electrostatics and the chapter 3 deals with current electricity. And what is electrostatics? It is simply a branch of physics which deals with charges at rest. And the branch of physics which deals with charges in motion is called current electricity. Basic difference is charges at rest and charges in motion, right? Okay. uh, just to learn how charge behave when it is at rest, we have been given two big chapters, chapter 1 and chapter 2. What uh, are there? What are the topics in these two chapters? Here you can see electrostatics deals with a study of forces, fields, potentials. In first chapter, we will discuss forces and fields, and in second chapter we will deal potentials. Okay, and from third chapter we will discuss charges in motion, right? So our main motto is, we know first what is charge. अगर हम चार्ज को जानेंगे समझेंगे तभी तो समझेंगे कि चार्ज जब रेस्ट में होगा तो वो कैसे बिहेव करेगा, मोशन में होगा तो कैसे बिहेव करेगा। ये जानने से पहले हमें ये जानना बहुत ज़रूरी है कि व्हाट इज़ चार्ज, राइट? So let's start, let us explore so many things to learn. This is the activity which shows which is very common activity to learn charge, to just have an experience of charge, right? What we need, a comb and some small paper pieces. Just run the plastic comb with your dry hair and bring it near paper pieces. You will see that the paper pieces get attracted towards the charged comb, right? Very common. This experiment can be performed with your plastic ruler in your pencil box also. Okay. In this experiment, there are so many questions which are definitely to be answered, definitely to be understood. First is why the comb is selected. Is there something special in the comb? Second point, whether the pointed needles have some role in this attraction. Third is why the paper pieces are selected very small. Next, what will happen if the hair is not dry? If it is, what will happen if it is wet? What will happen if it is oily? Okay. And one more thing, when we rub this comb, plastic comb, with our dry hair, we have to quickly bring it towards or near the paper pieces, then only the attraction is visible. If there is a delay, then we cannot see the attraction, or there will be very poor attraction. What actually happens when we rub plastic comb with dry hair, then the comb becomes charged, and because of this charge the paper piece get attracted. But when there is a delay, then the charge appeared on the comb because of rubbing passes through our body and just grounded, and then becomes uncharged, and hence unable to show the attraction to the paper pieces. Okay, so what is charge is still a question, and in order to understand the concept, we have divided it into two parts. One is old concept and another is modern concept. Okay, let's first discuss old concept of charge. Thales is a name of a philosopher around 600 BC, almost 2500 years before from now. Thales in Greece. Okay, he has performed some experiments on the basis of which charge is defined. Very clear, be very clear. Around 600 BC, some experiments were performed on the basis of which charge is defined. Here the first experiment is a glass rod is rubbed with a silk cloth and is brought near another glass rod rubbed with silk cloth. They are found to repel each other. The glass rod repels the another glass rod. Okay. After this experiment, they named the property attained on rubbing as charge. What was the name? Charge. Actual name in Greek language was electron. Elektron. We will say charge in English, right? After the first experiment, this property of repulsion by glass rod to another glass rod is named as charge. The glass rod is said to be charged. Okay. Now, another experiment is performed. Human beings are very curious to know. Someone thought, why only glass rod, silk cloth, why not some other object? Accidentally they found a new pair of objects which shows the same phenomenon, and it was plastic rod and cat's fur. A plastic rod is rubbed with cat's fur and is brought near another plastic rod rubbed with cat's fur. They are found to repel each other. Nothing new, and once again there is repulsion. They are said to be charged. The property attained is called charge. First experiment and second experiment almost common, and there is only difference of new objects. The pair of objects are different, but they both show the property called charge by showing repulsion. Right. Now there is experiment 3, which was actually a cross examination of the above two experiments. A glass rod rubbed with silk cloth is brought near a plastic rod rubbed with cat's fur, and surprisingly they are found to attract each other. This attraction is very different from the repulsion shown in the above two experiments. Since this property was attained on rubbing, once again it is said to be charged, but it is different from the above two experiments. So finally people concluded something, right? On the basis of these simple facts, it is established from years of efforts and careful experiments and their analysis that there is an entity called electric charge. Okay, there is a physical quantity which is called electric charge, which is attained on rubbing. We say that the body is like glass or plastic rods, silk, fur, cat's fur actually, and pith balls. Pith balls nowadays is replaced by polystyrene balls, are electrified or charged. They acquire an electric charge on rubbing. On rubbing, these objects attain a property called electric charge, because of which they attract or repel. Okay. Uh, on the basis of the experiment, since the charge is found to be of two types, sometimes they repel, on other hand they attract. So there are two types of charge. One is positive charge, second is negative charge. The positive and negative term was used by Benjamin Franklin. He was an American scientist. According to him, a logic, uh, according to him, he logically named positive and negative because we know that when we add a positive number to a negative number of the same magnitude, the sum is 0. A positive number when added with a negative number, the sum is 0. Okay, this might be the philosophy in naming the charges as positive and negative. Okay, final conclusion. By convention, charge acquired by glass rod or cat's fur is called positive. Glass rod is conventionally defined to have positive charge when rubbed with silk cloth. Okay, cat's fur when rubbed with plastic rod is said to have positive charge. Second point is charge acquired by plastic rod or silk cloth is called negative. Plastic rod is rubbed with cat's fur, attains negative charge, and silk cloth when rubbed with glass rod attains negative charge. Okay, and when there is no charge, the object is said to be neutral. And there are many such pair of objects. Right now, in the experiments performed 2500 years before, there are very few pair of objects, but you can have many pair of objects, and they can be positive and negative according to this listing. You can note down these two lists of positive charge and negative charge. Okay. Okay, now we move ahead towards the modern concept of charge. Because we directly go into the modern concept, we just brush up our uh, concepts of atom and elementary particles, right? Elementary particles means electron, protons, and neutrons. And when they were discovered, it is established that electrons are negatively charged, protons are positively charged, and neutrons are neutral. The charge on an electron is minus 1.6 into 10 to the power minus 19 coulomb. Charge on a proton is plus 1.6 into 10 to the power minus 19 coulomb. And charge on a neutron is 0. Okay. Next is an atom has equal number of electrons and protons. You know very well that an atom is consist of electrons, protons, and neutrons. There are certain number of electrons, protons, and neutrons, but the number of electrons are equal to the number of protons. Suppose we are having one sodium atom. Okay, you can see here uh, we take one sodium atom. It contains 11 electrons, 11 protons, and 12 neutrons, right? We are having the charge of electron, proton, and neutron. We know the charges of electron, proton, and neutron. Now we want to calculate charge of one sodium atom. One sodium atom means charge of 11 electrons plus charge of 11 protons plus charge of 12 neutrons. We have to add all these three, right? So what we have calculated as 11 into minus 1.6 into 10 to the power minus 19 coulomb. This is the total charge of 11 electrons. Charge of one electron is minus 1.6 into 10 to the power minus 19 coulomb. So 11 electrons have charge. 11 into minus 1.6 into 10 to the power minus 19 coulomb. Similarly, charge of 11 protons is 11 into plus 1.6 into 10 to the power minus 19 coulomb, and charge of 12 neutrons is 12 into 0, since neutrons have no charge. What will happen? The result is 0. Why? This calculation and this calculation will give you same calculation with only difference. First will have negative sign and second have positive sign, equal value with different sign. So in addition, the result becomes 0. Okay. Some more points regarding elementary particles. We know that electrons revolve around nucleus. Okay, electrons are part of an atom and they are revolving around nucleus in certain orbits. There are many orbits. Okay, protons and neutrons reside inside nucleus. प्रोटॉन्स और न्यूट्रॉन्स कहाँ रहते हैं? न्यूक्लियस में रहते हैं. इलेक्ट्रॉन्स कहाँ रहते हैं? न्यूक्लियस के बाहर अलग अलग ऑर्बिट्स में रिवॉल्व करते हैं. ओके, एंड you know something about metals and non-metals. Metals are those which are having fewer number of in its outermost orbit, like 1, 2 or 3 electrons, and because of this they are having a tendency to lose electrons, right? And in non-metals, their outermost orbit contains a number of electrons like 5, 6, 7, and because of this they are having tightly bound electrons with their nucleus. They are less tendency to lose, actually no tendency to lose, but metals can lose electrons. They have a high tendency to lose. Now come to modern concept of charge. What is modern concept? When two objects are rubbed together, especially if the objects are insulators and surrounding air is dry, the objects acquire equal and opposite charges and an attractive force develops between them. ओके, समझ गए क्या हुआ? जब दो ऑब्जेक्ट को आपस में हम रब करते हैं तब होता क्या है? उन पे इक्वल और ऑपोजिट चार्ज क्रिएट होता है और उसके बाद उनमें एक अट्रैक्टिव फोर्स भी क्रिएट होता है. वे एक दूसरे को अट्रैक्ट भी करने लगते हैं. क्लियर? 3 points are there. One is after rubbing they acquire equal and opposite charges, and after rubbing they attract each other, right? One becomes positively charged, another becomes negatively charged, and there is an attraction between them. Let us learn with this the concept with an example, very good example. We take a glass rod and a silk cloth. Both are initially uncharged, right? They are rubbed together, right? Then something will happen, right? What is here important is we take a glass rod, we take a silk cloth. The initial charge is 0. Both are neutral, right? Both are neutral. They are having no charge. Now they are rubbed together. On rubbing, many cases can arise, right? Let us discuss case 1. Suppose on rubbing there is a transfer of electrons, transfer of one electron from glass rod to silk cloth, right? Suppose there is a transfer of one electron from glass rod to silk cloth. ओके यहाँ एक बात और कहनी है, एक बड़ा सवाल जो स्टूडेंट्स पूछते हैं हमेशा कि इलेक्ट्रॉन्स का लॉस ग्लास रॉड ही क्यों करता है, सिल्क क्लॉथ ही एक्सेप्ट क्यों करता है? क्या ऐसा नहीं हो सकता कि सिल्क इलेक्ट्रॉन को लूज करे और ग्लास गेन करे? ठीक है, ये सवाल का जवाब देना यहाँ बहुत ज़रूरी है. Just few minutes before we have seen few experiments in which there are pair of objects. उन पेयर ऑफ ऑब्जेक्ट्स को गौर से याद कीजिए. हमने किनके बीच रबिंग कराई थी? एक ग्लास रॉड था, दूसरा क्या था? सिल्क क्लॉथ था ना. क्या ग्लास रॉड को ग्लास रॉड से रब कराया था? नहीं. ग्लास रॉड वाज रब्ड विथ सिल्क क्लॉथ, राइट? ग्लास को सिल्क से रब करने का क्या पर्पस है? वेरी सिंपल. Out of these two, one has a strong tendency to lose electron and another has a strong tendency to gain electron. And because of this tendency, a transfer of electrons is possible. But if the two objects are same, अगर दोनों ग्लास रॉड होते तब क्या होता? दोनों की एक जैसी टेंडेंसी होती. या तो दोनों लूज करने वाले होते इलेक्ट्रॉन्स को या दोनों गेन करने वाले होते. वैसे में ट्रांसफर इलेक्ट्रॉन्स पॉसिबल नहीं होता. सो होप आई आंसर्ड द क्वेश्चन. वी ऑलवेज सेलेक्ट टू ऑब्जेक्ट्स different and the reason is very clear. The selection is such that one is having a strong tendency to lose electron and another is having a strong tendency to gain electron. Okay, we have given a list also, one list of those objects which on losing electrons becomes positively charged, and there is another list where there are objects which has a strong tendency to gain electrons and become negatively charged. Okay, come to the point. This is case 1. Here हमने क्या माना? ग्लास रॉड से एक इलेक्ट्रॉन का ट्रांसफ़र हुआ है सिल्क क्लॉथ पर. कितने इलेक्ट्रॉन का ट्रांसफ़र? सिर्फ एक. हमने एक ही माना है. इसकी वजह से क्या होगा? ठीक है, इसको सीखते हैं, समझते हैं. देखिए, क्या था? ग्लास रॉड के पास कोई चार्ज नहीं था. इनिशियली द ग्लास रॉड वाज अनचार्ज्ड and silk was also uncharged, right? What will happen? One electron is now out from glass rod. ग्लास रॉड से एक इलेक्ट्रॉन चला गया है. एक इलेक्ट्रॉन चला गया है तो उसका चार्ज क्या था? 0 था. उसमें से माइनस हो गया. क्या माइनस हो गया? एक इलेक्ट्रॉन का चार्ज. माइनस मीन्स कम हो गया. 0 था, 0 में से एक इलेक्ट्रॉन के बराबर का चार्ज निकल गया. ओके, सिंपल से कैलकुलेशन कीजिए. 0 माइनस इलेक्ट्रॉन का चार्ज रखने पे माइनस and minus becomes plus. Okay, so this much positive charge is left on glass rod, plus 1.6 into 10 to the power minus 19 coulomb. सिल्क क्लॉथ के बारे में डिस्कस करते हैं. चार्ज कुछ भी नहीं था, 0 था. अब क्या हुआ? एक इलेक्ट्रॉन आया है ग्लास रॉड से सिल्क पे. तो एक इलेक्ट्रॉन के आने से क्या हुआ? ज़ीरो चार्ज पहले से था, उसमें प्लस हो गया। क्या प्लस हो गया? एक इलेक्ट्रॉन का चार्ज प्लस हो गया। ठीक है, तो 0 प्लस -1.6 इंटू 10⁻⁻19 कूलम क्या बन गया? -1.6 इंटू 10⁻⁻19 कूलम। ठीक है, समझ आया? तो ये आपने इस एग्जाम्पल में क्या देखा कि वन इलेक्ट्रॉन के ट्रांसफ़र होने से, जिसको आप कह सकते हैं ग्लास रॉड में वन इलेक्ट्रॉन का लॉस और सिल्क में वन इलेक्ट्रॉन का गेन। ठीक है, इसकी वजह से ग्लास रॉड बन गया पॉजिटिवली चार्ज और सिल्क क्लॉथ हो गया कैसा? नेगेटिवली चार्ज। एक पॉइंट। दूसरा और बहुत इंपॉर्टेंट पॉइंट ये है, दोनों पे चार्ज कैसे बने हैं? ऑपोजिट साइन के। ओके, ग्लास रॉड पॉजिटिवली चार्ज्ड एंड सिल्क क्लॉथ नेगेटिवली चार्ज। सेकेंड पॉइंट, दोनों का चार्ज इक्वल वैल्यू का है। ठीक है, +1.6 इंटू 10⁻⁻19 कूलम एंड -1.6 इंटू 10⁻⁻19 कूलम, है ना? ठीक, ओके। So the very important point that is noted here is this one. It is to be noted that equal and opposite charges are produced on the two objects. Okay, I think everybody understood. Next is the same one. The result is, final result is, on rubbing glass rod with silk cloth, if there is a transfer of one electron, then the glass rod has +1.6 into 10⁻⁻19 coulomb and silk cloth has -1.6 into 10⁻⁻19 coulomb. Okay, clear. Next is this is case 2. Case 2, what is here? The same two objects, right? Glass rod and silk cloth. They are rubbed together, and suppose rubbing is such that there is a transfer of two electrons from glass rod to silk cloth. Okay, so glass rod has a loss of two electrons and silk cloth has a gain of two electrons. Initially glass rod is uncharged and silk is uncharged. What will happen? The new charge will be 0, 0 minus charge of how many electrons? 2 electrons. दो इलेक्ट्रॉन ग्लास रॉड से चले गए। ठीक, कहाँ चले गए? सिल्क क्लॉथ में। तो 0 माइनस चार्ज ऑफ 2 electrons. 0 minus charge of 2 electrons. Okay, so after simple calculation you will see that this is plus 3.2 into 10⁻⁻19 coulomb. Similarly here also initial charge was 0, and so because 2 electrons has reached silk cloth from glass rod, so the charge becomes 0 plus charge of 2 electrons. So 2 into minus this much, 2 into charge of an electron, it becomes minus 3.2 into 10⁻⁻19 coulomb. Okay, understood? Okay. Hence, glass rod becomes positively charged and silk cloth becomes negatively charged, right? So finally, the result is this much, this one. On transfer of two electrons, glass rod becomes positively charged and silk cloth becomes negatively charged. Glass has plus 3.2 into 10⁻⁻19 coulomb and silk has minus 3.2 into 10⁻⁻19 coulomb. This is case third. Here we have taken transfer of 3 electrons. Okay, you can see transfer of 3 electrons. On similar line of explanation, you can find glass rod has plus 4.8 into 10 to the power minus 19 coulomb charge, and on silk cloth it is minus 4.8 into 10 to the power minus 19 coulomb. Glass rod becomes positively charged and silk becomes negatively charged. Clear? This is the result. Okay. Now, after discussion of the three cases, what are the conclusion? The first conclusion is the minimum possible charge. How the minimum possible charge is produced. Suppose someone asks you, कोई आपसे पूछता है बताओ सबसे छोटा चार्ज कितना होता है, ठीक है, कितना प्रोड्यूस कर सकते हैं, सबसे छोटा चार्ज, स्मॉलेस्ट पॉसिबल चार्ज क्या है. So there is this simple thought comes in our mind that the minimum possibility is loss of one electron or gain of one electron, right? So smallest possible, so the smallest possible charge is the smallest possible positive charge is plus 1.6 into 10 to the minus 19 coulomb, and smallest possible negative charge is minus 1.6 into 10 to the power negative minus 19 coulomb, and this is because of loss of one electron and because of gain of one electron, right? If there is a transfer of two electrons, then the next possibility is this one, okay, plus 3.2 into 10 to the power minus 19 coulomb minus 3.2 into 10 to the power minus 19 coulomb. Okay. This is an important listing of possible charges. Okay, possible charges कितने हो सकते हैं, कैसे हो सकते हैं, किस तरह के चार्जेस हो सकते हैं, कौन से चार्ज को हम कह सकते हैं, ऐसा तो पॉसिबल नहीं है, राइट? ओके, चार्जेस कैसे होंगे पॉसिबल, चार्जेस बनते कैसे हैं, बिकॉज ऑफ लॉस ऑफ इलेक्ट्रॉन्स एंड गेन ऑफ इलेक्ट्रॉन्स, राइट? सो there is a possibility of loss of one electron or loss of two electrons or loss of three electrons, loss of four electrons in whole numbers only. Is there a possibility of loss of 2.5 electron? No, in only whole numbers. Okay, loss of electrons, okay, like 1 2 3 4. Similarly, gain electrons like 1 electron, okay, added, 2 electrons added, 3 electrons added, like that. So the possibility is always in multiple of the charge of an electron or charge of a proton, right?